Hi there, here's another A-level maths video. Here we're going to look at a chapter 2 topic in the Pure Maths Year 1 textbook, section 2.3, where we're going to look at functions and how they relate to quadratics. So have you seen functions before? I know some of you definitely will have, maybe one or two you haven't. But function is really a relationship that takes an input value and maps it to some output value. And we use a notation there you can see on the screen. The function with the name of f would have an input value of x and is written like that, f with the x in brackets. So why don't we have a look at an example of a function here. So if I've got a function called f, then I would write f with an x in brackets here. And out loud I would say f of x. That's how I would say that. And let's say the rule is that it takes the input value of x and maps it to an output value which multiplies that input value by 7 and then subtracts 2. So I might write here f of x equals 7x minus 2. The x inside the bracket here would be my input, and the 7x minus 2 here would be the output of that function. Okay, so if you're not quite sure what this means, let me show you an example. Let's say I've got an input value of 2. So I would write f with the 2 in brackets, f of 2, I would say out loud. And really what I'm doing there, the answer to that would be 7 multiplied by the input value, and then subtract 2. And that means that we end up with 12 there. So in this particular example, f of 2 would give us the answer 12. So it's mapped the input number of 2 to the output number of 12. Let's have a look at one more quick example. So let's say instead of 2, my input number was actually 4.5. So my output number is going to be 7 times the input number, 7 times 4.5 minus 2. I think if you work that out, it becomes 29.5. So that must mean that f of 4.5 is 29.5. So why don't you have a go and see if you can do this one here on the screen. For the same function, f of x equals 7x minus 2, can you tell me the value of f of minus 1, please? Okay, so here's what we should have done. F of negative 1 means that we've got our input of negative 1, we multiply that by 7. And then we are going to subtract 2 from that. And we end up, I think, with the answer negative 9. So that must mean when the input is negative 1, the output is negative 9, or f of negative 1 is negative 9. Okay, so why don't we have a look at another example here. So let's say I'm going to look at a different function now. And I'll give it a different name, just for variety's sake. We'll call this one g. So g is the function which takes an input, x, and then maps it to the output of 25 minus x squared, we'll say. Now, you've seen how this works already. So I can take an input number. Let's say I'm going to take 3 as my input here. And then I could work that out just by substituting x for 3 in the formula up here. Okay, and in this particular case, we get the answer 16. So nothing too different there. You can just have a different rule here. And we can just, obviously, we'll get a different answer. But the great thing about this function way of writing things is that we can have inputs which are actually algebra. So let's say my input is some variable a. And that means my output here is going to be 25 minus a squared, because when I replace x with a in the input, I replace x with a in the formula, which gives me the output as well. Now, I can't simplify that, so I would leave it like that. We can go a bit more complicated. Let's say that I'm going to have an input of p plus q. So if I take g of p plus q, I'm going to replace the x wherever I see it here with p plus q. Okay, and that's what I'd end up with here. Notice I'm being very careful with the brackets here because all of the input here is being squared, so all of the input needs to be squared here. And so there we go, I've got an expression for g of p plus q. I could even take another expression involving x. Okay, so here the function is defined as taking an input x and mapping it to 25 minus x squared. But if the input was 2x, then my output here would be 25 minus 2x all being squared. And again, you can see I'm being very careful with my brackets here because it's all of that input which is being squared here. So why don't you see if you can get your head around this idea of using an algebraic input for a function. Same function on the screen here. Pause the video and then find the expression for g of x plus 1. Okay, so how did you do with this one? Here's what we should have done. G of x plus 1, in this particular case, is going to be 25 minus the input, which is x plus 1, all being squared. Okay, so I know that some of you will have definitely seen functions before, and none of this we've done so far will be new to you. But maybe there's some of the definitions on the screen might be new to you. So we're going to be doing function work or work with functions a lot in the rest of the course, a bit later on down the road. But for now, here's some important stuff that we do need to know about functions. The set of the allowed input values for a function, so that's our x in our notation, is called the domain of the function. And quite often, that's just going to be any real number. So any number, whether it be positive, negative, fractions, decimals, stuff like pi, anywhere that's on the number line, that's a real number. And you'll see the notation on the screen there. It looks a bit weird. We've got an x, we've got a thing which looks a bit like a letter E, but not quite. And then we've got a bolded up letter R here. That's read out loud as x is a member of the set of all real numbers. And I don't think you need to worry too much about that, but if you see it, just know that it means that x could be any real number. Okay, the set of possible output values of the function, so that's what we get, the numbers which the x values map to. That whole set of numbers is called the range of the function. And sometimes we're interested in the input values which give an output of 0. And we call those the roots of the function. So let's see if we can just find the roots of a particular function here, which I put on the screen. So the function is, we've called it f again, and it's a quadratic function. You'll see x squared minus 4x minus 21. And then this is just telling us that x is, or input numbers, is just a member of the set of all real numbers. Okay, so it just means that there's no restriction really. Any number on our number line we can use as an input number. Okay, so if we were after the roots of this function, we're basically looking for where these output numbers, in this particular case the x squared minus 4x minus 21, is 0. And we want to find the x values which give us that. Well, hey, this is just a quadratic equation, and we're used to solving those by now, right? So we can use whatever method we like to solve this equation. I think this one is going to be nice to factorize. So if we factorize that, I think it becomes x minus 7x plus 3. Which then leads to the roots of the function as x equals a positive 7 and x equals a negative 3, which comes from that one there. So do you get the idea? All we're doing here is, if we want to find the roots of a function, take the output formula, set it equal to 0 and solve the equation. Okay, so here's one for you to have a go at. It's another quadratic one, but this one, you'll notice I've written it in completed square form. So if you can find the most efficient way of finding the roots of this function. Okay, let's have a look at the answer here. So what we're trying to do here really is we're trying to take the output of the function, which is the x minus 2 all squared minus 9. We're setting that equal to 0 because we want to find the input values x, which give us an output of 0 here. Now, did you find the most efficient way of solving this one? Remember what we did in our completing the square video. One of the reasons why we might want to complete the square is because it makes quadratic equations a bit easier to solve. So we can just rearrange it and find the value of x. Let's start off by adding 9 to both sides. Then we will take the square root of both sides. Now the square root of 9 is of course 3, but what do I need to remember? I need to remember that this can be plus or minus. Okay, add 2 to both sides, so we end up with 2 plus or minus 3 as our roots of the function here. So let's just write down what we get there. So if it's 2 plus 3, that is of course 5, and if it's 2 minus 3, that is of course negative 1. So the roots of this function on the screen are x equals 5 and x equals negative 1. What else might we want to do with functions? Well, one of the things you could be asked to do is determine a minimum or a maximum value of the function. And what this really means is we're looking for the smallest possible output of the function if we're asked for the minimum value. If we're asked for the maximum value, that would be the largest possible output for the function. And when we have quadratic functions, this completed square form is really actually the easiest way of finding that. So let me show you how that works here. So let's say I've got my function. We've got the same functions we've just been dealing with here. It's called g of x, and it's going to be defined as x minus 2 all squared minus 9, and x could be any real number, so I'll put that down here. We're not restricting our input at all. Now, how are we going to find the minimum possible output value of this function? What's the smallest output we can get, and what value of x gives us that? Well, the trick here is to notice that we've got something being squared as part of our function. And when we have something being squared, then we can never get a negative answer for that bit of the function, right? Whenever we square a positive number, we get a positive answer. Whenever we square a negative number, we still get a positive answer. When we square 0, we get 0. So the minimum value that we can get out of this little part of the function here is got to be 0. And that means that the minimum value of the function g of x, the minimum output we could get, has got to be 0 minus the 9 that we've got here, which is of course negative 9. So there is our minimum value that we can get out of the function, and we got that by using this trick and recognizing that something squared can never be negative. The smallest it can be is 0. Hope that makes sense to you. All right, we've been asked to do one other thing in this question. We've been asked to state the value of x for where the minimum occurs. Well, we need to answer the question, what value of x gives us a 0 in this bracket? So we just need to kind of think that x minus 2 equals 0. And that, of course, means that x must equal 2. So that must mean that the function here, when x equals 2, we get an answer of negative 9 coming out. And that's the smallest possible answer we could get coming out. So yet another reason why completed square form was really, really useful for us, because it allows us to just almost read off quite quickly what the minimum value of that quadratic function is and value of x, which gives us that minimum value. Okay, right. Let's see if you can do one yourself. Again, another function here. I've put it into completed square form already for you. Can you state the value of x for where we have that minimum value, and also what that minimum value is, please? Okay, so recognizing that the squared term here has a minimum value of 0, it must mean that the minimum value of the whole function, so the minimum of the whole function here, bring that in here so we can see that better, there we go, is going to equal 0 plus 10 here, which is of course 10. The value of x, which gives us that minimum value for the function, for f of x, must be the value of x which makes this bracket equal to 0. So that's going to be when x plus 3 over 2 equals 0, which is of course leads us to x equals negative 3 over 2. So the answer is the minimum value of the function is 10, and that will occur when x is negative 3 over 2. Okay, hopefully it's all making sense so far. Now, there's one last thing in this section. This is quite a long section. There's quite a lot in this section, isn't there? So one last thing which the textbook covers here, and that's where we have functions which I'm going to call quadratics in disguise. They don't look like quadratic functions because we can't always see an x squared term, but they are of a quadratic form. Here's an example on the screen of the kind of thing I'm talking about. So you see here we've got a function which is called h, and it's x minus 8 root x plus 15. And we've been asked to find the roots of that function. Now that of course means that we're trying to solve the equation where x minus 8 root x plus 15 equals 0. And that looks pretty complicated, right, with this square roots going on here. But here is the trick. I'm going to introduce a new variable. I'm going to call it y, and that's going to be the square root of x. So when I do that, it means my equation just becomes this. Okay, do you see what I've done there? Do you see what's happened? The square root of x, I'm now just calling y, and it means that x is going to be y squared, because x is going to be the square root of x, but then squared again. And it turns into this quadratic equation. So do you see what I mean when I talked about a quadratic in disguise here? It is a quadratic equation, the original one. It's just a quadratic not in x, but in the square root of x. Okay, if I now just quickly solve this one here, I'm going to factorize this one, so we end up with y minus 3 times y minus 5 equals 0. And that gives us solutions here that y equals 3 and y equals 5. But of course, our original equation was in terms of x. We know that y equals the square root of x, so it must mean that the square root of x equals 3, or the square root of x equals 5. And that leads us to our roots. Square both sides of this. X is 9, or x equals 25, and those are the roots of the function. Okay, so on the screen there, there is another quadratic function, but a quadratic in disguise. Hopefully you can take the clue that's on the screen there. X to the power 4 can be written as x squared all squared. And maybe if you want to introduce a new variable, you could say that y equals x squared here and try and write the function in terms of y. Anyway, see how you get on, and restart the video once you've got your answer. Okay then, so did you pick up on the clue here? What we can do is we can let y be x squared here. So that means that my function here is going to become y squared minus 13y plus 36. And if we're trying to find the roots of that function, we need to solve the equation where that equals 0. Now, I'll just jump to the answer here for this. If you solve that equation either by factorizing or using the formula, or however you want to solve it, you should end up with y equals 4 and y equals 9. But of course, our function is in terms of x, so we need to use the fact that y equals x squared here. So that leads us to x squared equals 4, or x squared equals 9. And then we end up with, that must mean that x equals plus or minus 2, or x equals plus or minus 3 when we take the square root of both sides. And hopefully you did not forget the plus or minus here. So 4 roots to this function: positive and negative 2, positive and negative 3. Okay, now I think that's quite a lot in that little section, right? Because we had to learn about functions, you know, what they are and how they're represented. We looked at how we can find the minimum points of quadratic functions by looking at the completed square form, and we also looked at these quadratics in disguise. So lots and lots and lots of consolidation that you might want to do here, because there's lots of different ideas in this section of the textbook. But that's it for this video, and I'll see you again next time.